Welcome. In this lecture, we'll talk about measures of central tendency. Now, before we begin understanding what are the measures of central tendency, let's understand representative value. For example, when a country has to represent at an international portal, it's not that all of the members of the country start to go and represent the country. Few of the elected or nominated delegates would go and represent the country. So what does this show? This shows the representative value. Similar is the case with the statistics. Whenever you are doing any kind of research, the idea is you are trying to represent the whole information that you have, and this could be brought about either by bringing in averages, either by bringing in variations. So there are different ways under which we can explain the phenomena. So whatever is happening could be explained keeping in view, keeping in light certain things, and this is what is representative value. So for example, for a country, the president or the prime minister would be a representation for that nation. Similarly, if you are in a classroom, the class representative is a representation for the class. Rather than all the students from the class going to the principal room, it's just the class representative that would represent all your views. Same goes with the statistics. It's just the values are changed, and here you have numbers. You would be playing with numbers. Now, this representative value could be explained in two different ways. The first way is where you consider understanding the mean, and this is through the measure of central tendency. We explain this as mean, mode and median. So mean, mode and median that we would understand would be one by one. So we would talk about the measures of central tendency. Under central tendency you would have mean, median and mode. The next is the variability. Under variability, how things vary is something that is explained, and this is represented by two ways. One is variance and the second is standard deviation. So all this falls under the idea where you are describing how numbers are spread in a group, how different scores are there and how the variations are there. So measures of central tendency, as already put, are classified under three. You have mean, median and mode. For now, we would focus only on mean. So let's begin with mean. This mean can further be classified into three types. You have arithmetic mean, geometric mean and harmonic mean. Again, this arithmetic mean could be classified under three groups. It can be a simple mean, it can be a mean with frequency and a weighted mean. Now we will understand this one by one as we proceed. So this is an overview of the measures of central tendency. Coming on to the first one, that is mean. It is one of the best measures of central tendency where you are trying to explain an ordinary average. So all the scores are divided by the number of the scores that are there. Let's say I have three kids here. One is little short, just 2 feet, the next is 4 feet and the third one is 6 feet. Now all these three kids, if I want to find the average, how can I understand it? The sum of the values of the height of these three kids would be 2 plus 4 plus 6, and that accounts for 12. Now we divide it by the average, by the number of the kids. So how many number of the kids? 3. So divided by 3 and we get 4, and we can say 4 is the average value that's there. Now with the same example, I have the kids 2 feet, 4 feet and 6 feet. I increase the height of this kid and decrease the height of this kid. Now all the three kids are of 4 feet. So when all the three kids are of 4 feet, what would happen? It would become 4 plus 4 plus 4, and that makes it 12 again. Divided by the number of the kids, which is 3, you have the value which is again 4. So my average in both the cases remains 4, and that's very, very important. The idea is the number of the kids multiplied by the weights that are there would give you the total value. Okay, so in the first case you have 2 feet and 6 feet, that the total comes out to be 12, and this total is equal to the multiplication of the average and the number of the kids that are there. So that's how we understand the mean. Now this same mean I can manipulate it with frequency. How can I do it? Let's say I have a level ground. On this level I have a pointer that would indicate the mean value. What I do is I just slide that pointer to adjust to the mean value. On the first I have 2 kids who have 2 feet of height. I have 4 kids with a height of 3 feet, and I have 4 kids again who have a height of 5 feet. So 2 kids with height of 2 feet, 4 kids with height of 3 feet, and I have 4 kids with a height of 5 feet. Now what I do is I find the total. So this total could be 2 plus 2, there are 2 kids of 2, or I can do 2 into 2. Similarly, there are 4 kids of 3 feet height, so I can do 4 into 3, or I can do 3 plus 3 plus 3 plus 3 4 times. And similarly, so when I add all these values, so it is the multiplication I can do it as 2 kids of 2 feet plus 4 kids of 3 feet plus 4 kids of 5 feet. So that's 4 plus 12 plus 20. So that's 16 plus 20, 36 divided by the total number of kids, which are 2 plus 4 plus 4, that is 10. So 36 divided by 10 is 3.6 feet. So this becomes my mean, and when I have the pointer on the rod, I can adjust it towards the side more than 3 feet and less than 5 feet, and it would be somewhere between 3 and 4 as 3.6, and that is my mean with the frequency that I have calculated. So you have the same number 2 feet height, but there are more than 1 kids, so we consider this as frequency. Clear? Now how do we express mean? Mean is simply expressed as summation of x divided by total number of scores, or the summation of all the heights in this case divided by total number of kids that are present. The next case, as I said, so 2 cases done, the general mean, mean with frequency. Now we have weighted mean. How do we understand weighted mean? This is very simple. Let's say you are in an examination hall and you have the marks weightage that are given for the examination. So let's say the teacher says your homework would have a 25 weightage, classwork would have a 50 weightage, and the final test or the exam would have 25 weight. So this is the weight. Now what are your scores for the homework, classwork and the test? Let's say in the homework you score 70, in the classwork you score 80, and in the test you score 60. So what is your weighted mean? So weighted mean is calculated as the average by multiplying weights with the score and dividing it by the weights. So it's the summation of weights and the scores divided by the summation of the weights. Now here we can say it's 25 into 70 plus 50 into 80 plus 25 into 60 divided by 25 plus 25 50, 50 plus 50 100. So divided by 100, that makes it 7250 divided by 100, that is 72.5 would be my average score that would be generated, and this is the weighted mean. So understand it very carefully, very precisely, what is a difference between a normal mean, a mean with frequency, and a weighted mean. Now after this, the next thing that we talk about is further interesting, and this is the geometric mean. Now let's take two numbers. I have 4 and 9. So the geometric mean is the square root. In this case, since there are two numbers, we take square root. If there were 3 numbers, we would take cube root. If there are n numbers, we will take nth root. So let's say you have 5 numbers, so you would have 5th root of n1 into n2, so on till n5. Okay, so that's how you calculate. So here you can either take the square root separately, so I can mark it as 2 into 3, that is 6, or I can multiply this within the square root, that is square root of 36, that again comes to be 6. So this is the geometric mean. Now I do a very interesting calculation. With the same two numbers, I do a arithmetic mean, and my arithmetic mean comes out to be 13 divided by 2, which is 6.5. Now you can apply it to n number of cases, but the final result that you would get is the geometric mean is always less than or equal to the arithmetic mean. It cannot be more than the arithmetic mean. That's rule number 1. The second rule is a very special characteristic of a geometric mean, that is understanding the ratios. So here I take the lower number divided by the geometric mean, and I take the bigger number, which is 9, and this is divided by the geometric mean. In both the cases I get a ratio of 2:3. So when I write the geometric mean as 4, 6 and 9, I take the ratio of 4 by 6 and 6 by 9. The ratio remains the same, and this is one of the very classic characteristics of geometric mean. A very, very important concept. The next is the harmonic mean. So when I say harmonic mean, it's just a reciprocal of the arithmetic mean. So let's say I have numbers 1, 4 and 4. I have to take out what? I have to take out the harmonic mean. So in this case, it would be 3 divided by 1 by 1 plus 1 by 4 plus 1 by 4. So it's half plus 1. So it's 1.5, and then I solve it. Okay. So I get a value here which is. Now, when I solve these values, what is very, very important to understand? So the harmonic mean came to 2. Now for the same numbers 1, 4 and 4, I calculate my arithmetic mean. What is my arithmetic mean? My arithmetic mean is the sum of these 3 digits divided by the number of digits, that's 3. So it's 9 divided by 3, and that's 3. So that's my arithmetic mean. Now if I want to find out the geometric mean, how it would be? Geometric mean is equal to cube root of 1 into 4 into 4. So what it would be? It would be, I can expand it as 2 into 2 into 2 into 2 and cube root. So it would be 2 outside and cube root of 2, and that's my geometric mean. So if I put all these together, I can say harmonic mean would be less than or equal to the geometric mean, which would be less than or equal to the arithmetic mean, and that would stand always true. However, when I want to calculate a relationship between the things which are the harmonic mean, geometric mean and arithmetic mean, how can I do that? I can simply say arithmetic mean into harmonic mean is equal to square of geometric mean. But that would stand only and only true when I have just 2 values with me. So when I had 3 values, my values as we calculated, the harmonic mean came to 2, the arithmetic mean came to 3, and the geometric mean came to 2 cube root of 2. And when I try to solve this and put this in this equation, it won't suffice. Now let's change my values. My new values are 4 and 4. With just 2 values, I calculate all of these again. So I calculate my arithmetic mean. My arithmetic mean is 4 plus 4 divided by 2, and that comes to 4. My harmonic mean is 2 divided by 1/4 plus 1/4, and that again comes to 4. And then my geometric mean is square root of 4 into 4, that again comes to 4. So what I do is, when I say arithmetic mean into harmonic mean, that is 4 into 4 would be the square of the geometric mean, and that stands true. But that would only and only be true only when I have 2 variables with me. Just with 2 values. As soon as the number of values changes, my answer won't suffice this equation. So that's very, very important to understand, and most of the places you won't find this on accuracy. Another important rule that you need to understand is, when I say harmonic mean, it is the reciprocal, listen carefully, it is the reciprocal of the arithmetic mean of the reciprocals. Okay, so it's the reciprocal of the arithmetic mean of the reciprocals, and that's why we say when in the case of 1, 4 and 4 we calculated the harmonic mean as 2 and the arithmetic mean would be 3, but here it would be 2 divided by 3 by 2 by 3, and that's the reciprocal of the reciprocal of the arithmetic mean of the reciprocal. So this is the arithmetic mean and the reciprocal of that. Let's begin with median. Now, in the measures of central tendency, we have already understood what a mean is. Mean is the average value. However, when we talk about median, it is the mid value. So let's take and continue with the last example that we did. So we have, let's say, 9 kids that are there, and the height of those 9 kids I have mentioned here. So these are the heights of those 9 kids. So I have these 9 kids that are there. Now what would be the mid value? In this case I can easily say 1, 2, 3, 4, 5, 6, 7, 8 and 9. So you have these values and the mid value would be this one which falls in the middle. So it is 4.5. Now what are outliers? So in the median, what we do is we take all the values, we arrange it from lowest to highest, and once we arrange it from lowest to highest, we find out the middle value. When the values are odd, okay, so let's say in this case there are 9 values that are there. So when the values are odd, it would be n plus 1 by 2th value that would be there. So 9 values, 9 plus 1 by 2, that is the 5th value. So here I count, it is the 1st, 2nd, 3rd, 4th and 5th value that's there, and the 5th value is the mid value. However, what would happen when the scores are even numbered? So let's say I remove 6.5 and I have even scores there. So I have these scores which are here. Now these 8 scores that are there, what would be the median for this case? For the even values, what I do is n by 2th score and n plus 1 by 2th score. I take the average of these two scores. So what is the n by 2th plus 1 score? So it is the 4th value and the 5th value. I leave 3 values from each of the side. So I have the 4th and the 5th value. I take the average of the 4th and the 5th value. So I take the average of 4 plus 4.5 divided by 2. So it's 4.25, and this 4.25 is my median, which is the middle value of my score. Now what would happen? Let's say I take another example. Now this example is pretty interesting. I have a child playing a video game. Now in the video game he has to shoot onto the range. When he presses the buzzer, there is a shoot that is done. So he presses the buzzer on the following seconds, let's say. So the presses are at 2 second, 2 second, 2 second, 3.2 second, 3.5 second, 4 second, and one of the presses takes, let's say, 10 second, because suddenly there was a call from the mother or there was another friend who came in and disturbed him. So in this case what happens is this value of 10 becomes an outlier value. It is a value that was because of the distraction that was caused while playing a video game. Now this outlier, when it comes to mean, what I would do, I would take all these values, I would add up all the values and divide it by the total number of values. So this outlier value would be counted in the process of mean. However, when I take the median, what would happen? I have to simply find out the mid value. So the mid value would be the average of 2 and 3.5 in this case, and that would be my median, which is my average value. So in very simple terms, median is independent of the outlier or the extreme values. Let's talk about the last example that we did, which was arranging the kids by their height. So definitely a kid of 2 feet in height, adult of 2 feet in height, and a person of let's say 6.5 feet in height are outliers, are extremes. You won't find it a normal circumstances. So those extreme values are ignored in the case of a median, but those extreme values are part of your mean or the average that you calculate. So it's very important to understand that median de-emphasizes any kind of extreme values or outliers that are there. Now let's talk about another measure of central tendency, and this is mode. Mode is a very important characteristic. With the same example of the video game, let's say the child has a reaction time where he is able to press the buzzer at the following seconds. Now in the same example, what is the mode? Mode is 2 in this case, because it is the maximum number of instances that the boy has. So most of the time he is able to press the buzzer at 2 seconds, and therefore this 2 second becomes the mode. So very clear what is the difference between a median, a mode and a mean. Mode again is independent of any kind of outlier values that are there. In this case 10 is an outlier value, but since it's only once, it's independent of that outlier value. However, what would happen in the case of mean? With the same example as explained before, the mean would be affected by any of the extreme values. And therefore, sometimes it is believed that mean is a measure of central tendency which is commonly used, but the most common thing that we understand is median is considered as a much better representation because it has an idea to de-emphasize onto the extreme values and focus on to the mid value that is there. The next thing is the most interesting aspect, comparing the mean, mode and median. We have already talked about the normal distribution curve, the concept of skewness and kurtosis in our previous lectures on the introduction to statistics. So you can just refer that back. In a normal distribution curve, what happens is the mode, median and mean, all of them are at a common location. Why? In this case, when it's a normal distribution curve, my mean value would be the middle value because it can exactly overlap as we have seen previously. So this is the mean value. Again, this is the place where you have highest number of frequencies. So mode is again here, and obviously the mid value is in the between. So you have the median also on the same position. So the mean, mode and median are equal in this case. Next comes the example of negatively skewed. Since it's a negatively skewed distribution, you have lots and lots of values which form the tail. Now, since there are lots and lots of values on this side, we call it as left skewed. So you have mean that would be closer to most of the values that are there because you have a long tail and you have numerous values here. So the mean or the average would be closer to the tail. Obviously, this is the mode, which is the frequency, the highest number of instances that are recorded, and mid value is the middle value, or median is the mid value that is there, and that would fall exactly midway between the total number of instances taken. So in this case, we say mean is less than median, and this is an example of negatively skewed curve. Clear? In this case, there is no perfect overlap that is seen as in the normal distribution curve. The next is a right or a positively skewed curve. So under a positively skewed curve, you have numerous values that are towards the right. Since there are numerous values towards the right, your mean would be towards the right. Your mode would definitely be here, which is the highest instances, and this would be the median. But in this case, your mean value is much higher than the median value, which is higher than the mode. So the difference between a negatively skewed curve and a positively skewed curve is now very obvious. The next important quick recap of understanding the measures of central tendency are understanding the difference between the mean, mode and median. So mean, I repeat again, it's the average. So the sum of all the scores divided by the number of scores would lead to mean. This mean usually has equal interval variables. So every fifth, every 10th, and the spacing that is there is equal interval, and this mean is most commonly used in all psychological researches or any kind of statistical researches that are there. Now let's consider a fact where you have to calculate standard deviation, variance. All of those would require mean. So mean is the foundation stone. You must know it. The next is mode. Mode means the greatest frequency. The highest number of instances of a common value that is there is what is mode. Mode is usually seen with nominal values or nominal variables that are there. So when you have just the variables that are there and you find out which instance has the highest number of cases, it's just the frequency you are trying to focus on, and that is mode. The last one is a median. What is median? Median, as we said, is the middle value of the distribution. So you arrange the scores from lowest to highest and find out the mid value. If it is an odd score or odd number of scores, it's very simple. You keep the values on both the sides, take out the middle value. However, if there are even scores, you take the average of the middle two values. So that is how you calculate the median, which is the mid value. Median is applied in the case of rank order variables. So whenever you are ranking first, second, third, in that case you would apply median, and this distribution works fine when you have outliers. So if you have one or two extreme outliers, it's independent of it. It does not bother about those outliers. But what would happen if there are many outliers? If there are many outliers, those outliers would no longer remain an outlier and they would become part of the normal distribution then. So it's very important to understand what we demarcate as outliers. When there are very few extreme values that are there, those are outliers. Outliers affect the mean. Outliers do not affect the mode and the median, and this median, however, I can say it's much more better in the case of outlier values. It's much rarely used as compared to the mean. So those are some of the basic techniques or measures of central tendency. We would continue with the variability and the variance. So let's talk about variability. Now when we focus on variability, we have variance and standard deviation, the two commonly heard terms in statistics. But let's have a broader picture about variability. Now let's say it's about to rain today. So what's the variability? If it is very cloudy, I can say there are 80% chances. If it is mediate cloudy, I can say 50% chances. If there are no dark clouds that are around, I can say 10% chances. So that's where we are trying to establish variations. Now, whenever we talk about statistics, this variability is a very key component. Let's understand it in simple fashion. I have 3 or 4 sets of observations that I have. Now these are my dreams. Every day I wake up, I have certain number of dreams in my mind. So let's say first day I saw 2 dreams. Next day I saw 3 dreams. Next day I saw 4 dreams. And the last day I saw 7 dreams. On these 4 days there were these values of the dreams that were seen. Now these dreams, when I am trying to understand what is the mean, I can simply say 2 plus 3 plus 4 plus 7 divided by the total number of observations, which is 4. I solve this comes out to 4. So the mean value of my dreams is 4. Now listen carefully. What would happen if I change this value? I decrease it by 2, I increase it by 2. So my new values are 2, 1, 4 and 9. Again, my mean would remain the same, which is 4, but my variability has increased. Now, when the variability has increased, what does that mean? In these cases where we see you have equal instances for the mean values that are there, but the variability is different. In this case, you have all the values which are closer towards the mean, but in the other case, you have all the values which are away from the mean, but still the mean remains the same, and that's where we understand the variability. In the next instance that we are trying to discuss is, we have different means, but the spread is more or less the same. So here we have the values of the mean that are different, but the spread is more or less uniform. Now, simply put, I can summarize this in one statement. If the values are closer to the mean value, I can say the variation or the variability is less. If the values are away from the mean, the variability is higher. Now, this variability could be accounted in two terms. The first is variance, the second is standard deviation. We always understand variance first and then we move on to standard deviation. Now, when I say variance, I am trying to understand the spread out scores across the means. So, whatever the mean is, how the scores have been spreading across it are very, very important to understand. Now, if I put it in a definitional form, what would be the definition? I can simply say it is the squared deviation scores that are seen. Let's take the same values of the dream. So those are 2, 3, 4 and 7. My mean comes out to 4. Now what is the deviation score? So in the first case it's 2 minus 4, 3 minus 4, 4 minus 4 and 7 minus 4. It comes to minus 2, minus 1, 0 and 3. When I sum up these values, my answer should be 0, and this is the value of deviation score. Very, very carefully understand the terms. Now deviation score must be 0 or very close to 0. That's one of the basic requirements to have a correct interpretation for the variance. If it is not the case, there has been some calculation mistake for sure. The next step we do is we square these scores. So I square minus 2. So always when you are squaring minus 2 into minus 2, minus minus plus. So you have 4, 1, 0 and 9. I add up these values. So these values comes out to be 10 and 14. 14 is my value, which is the sum of the squares. Now variance, I can simply say, is the summation of x minus x mean square divided by the total number of values that are there or the scores that are there. So here this value comes out to be 14 divided by number of items 1, 2, 3 and 4. So divided by 4. So this gives me the variance. Now be very, very careful where we are going. Let's say I change one of the values. Okay, there is one extreme value that is introduced into the system, and let's say that extreme value is 30. Now when I introduce this extreme value 30 into the system, what would happen? The mean would change, but the corresponding variance would also increase. So even one outlier would affect the value of the variance. Another very important point, that outliers affect the values of the variance. Variance, as I said, could be explained in this fashion or could be explained as sum of squares divided by the number of scores that are there. But if you are using, let's say, scientific calculators or any statistical softwares like SPSS, the values that you get for standard deviation and variance could be a little variant from the values that you actually get when you are calculating by your hand. Why does this happen? This happens because these systems rely on the unbiased estimate of variance. And what is this unbiased estimate of the variance? When I say unbiased estimate of the variance, let's understand this term first. So let's say I have the whole value that we are, let's say there are 10 items, the 4 items in this case that we took for the dreams. So when I have all the values, I am trying to understand all the values, I get and divide the variance, the square of the sum of squares by n. But let's say I have 10,000 people around. Of that, I am sampling some of those. So I sample 10 people. Now when I am sampling 10 people, the variance that is being obtained from the sample would be less than the true variance, and therefore in order to neutralize that, what we do is sum of the squares divided by n minus 1, and that's one of the ways under which we have unbiased estimate of population variance that is taken into account. So whenever we are talking about variance, when you have the actual number of cases that are there, the true scores that are there, you find out the values and divide it by the total number of scores or the total number of items that are there. But in case there is a sample that is taken into consideration, we, in order to have an unbiased estimate, we divide it by not by n but by n minus 1. A very important criteria, and this is where we have a difference in the answers. So if you are using scientific calculator or SPSS or StatLab, you would have a little variation in the answer as compared to this value, because these values, these softwares would be using n minus 1 as the base. However, when we do the calculation, we use it as n. One very important concept. The next important understanding here is this unbiased estimate is used in t-test, which we would be understanding in our higher classes of statistics. So as we proceed with more statistics, more depth in statistics, we will be covering those topics. Okay, so this is about variance. Now, few important things again. When I calculate the deviation scores, I add up all the deviation scores, my answer would be 0 or somewhat very close to the 0, and in that case I am going correct. And when I calculate my variance, I have the values as the sum of the squares divided by the number of the items. So in that case we had 3, 2, 4 and 7. My sum of the squares was 14 divided by 4, and this was my variance. What is the standard deviation? In one simple term, I can say the root of variance is what is standard deviation, and root of 14 by 4 would give me the answer as standard deviation. As simple as that. Okay, but sometimes there is a very common mistake that students do. They do not calculate the variance first. When they are trying to calculate the standard deviation, they simply calculate the sum of the squares and try to take a root of that. That's not correct. Sum of the squares divided by number of the scores, that gives you the variance, and under root of variance is what is standard deviation. Again, since variance is highly affected by outliers, same is the case with the standard deviation. So standard deviation would also be highly affected by the outliers. Now, let's say you have 100 as the variance. What would be the standard deviation? Very simple. So under root of 100, so that's 10 into 10 root, that gives you 10. If it is 9 as variance, what it would be? 3 into 3 under root, so that gives you 3 as variance. Again, a simple definition. Variance is a square deviation from the mean, and under root of variance is the standard deviation. So standard deviation, I can say, is the average amount that the scores differ from the mean value, and that's where we understand the standard deviation, which describes the spread in the group. So under variability, we talked about standard deviation and variance, and this whole lecture of the measures of central tendency incorporates mean, the types of mean, median, mode. We have talked about the skewness and the variation with the mean, mode and median, and finally coming on to variance and standard deviation. We'll be covering many more topics in statistics, so stay subscribed. Have a wonderful day ahead.